Hello, welcome to Wisdom Academy PH. So now we will discuss about vertical and horizontal asymptotes. So this lesson will be the third of our series about limits and continuity. So let's start. So let us consider this function 1 over 2x squared. We are tasked to find its limit at x approaching 0. So when we use direct substitution in this, we will get 1 over 0. So in these cases, before, we said that we denote this as limit does not exist. But now, we will discuss another denotation for these kinds of limits. So, let us consider this function. Tignan muna natin ngayon kung ano yung magiging value niya when x approaches 0. So, we will use the table method na ginawa natin when we discussed about limits. Let us consider values at 0.5, 0.2, 0.1, and 0.001. On the other side, so negative 0.5, negative 0.2, negative 0.1, and negative 0.001. Their equivalent values are 2, 12.5, 50, and 50 million. So, as we can see, habang lumalapit nang lumalapit si x to 0, nakikita natin na yung value, pataas lang ng pataas. And hindi natin alam kung hanggang saan siya nagsa-stop. So, kung titignan din natin yung graph ni 1 over 2x squared at x equals to 0, kita natin na ganito lang siya. Pataas lang siya ng pataas ng walang limit. So, kapag sa mga gantong cases na pataas lang siya ng pataas, we will denote it as positive infinity. So, instead na does not exist, sa mga gantong cases, we will use positive infinity. So, kapag naman pababa naman siya, for example, pag ganito yung graph, we will use the denotation of negative infinity. Okay? So, ganun lang siya. So, if mapapansin nyo, kung bakit ang title natin is vertical and horizontal asymptotes, kasi infinite limits are used to denote vertical asymptotes, as you can see in the graph. Okay? And so, infinite limits are used to denote vertical asymptotes. And take note that infinite limits does not mean that the limit exists. Remember na infinity is not a real number. So, ano lang natin siya? Sign lang natin siya para i-denote na pataas lang ng pataas yung number, pero hindi siya umaabot sa kahit saan. So, indefinitely lang siya tumataas. So, in general, kapag nakakuha tayo ng constant over 0, where constant is not equals to 0, infinite siya. Pero, yung sign, yung kung paano natin malalaman. So, simple lang. So, if positive si 0 na denominator and positive si numerator, edi positive. So, negative over negative din, positive infinity. So, ganun din, negative over positive, tsaka positive over negative, negative infinity. So, sign conventions lang yung magiging problema natin dito. So, kailangan lang natin tignan yung sign ni numerator and denominator para malaman kung ano yung sign ni infinity. Okay? So, ayun. If we remember yung example natin dun sa ating first lesson na limit of this function as x approaches 3 does not exist. Sinabi natin na does not exist siya kasi maging 13 over 0 kasi siya. Pero if maka-encounter tayo ng constant number over 0, ang gagawin natin dyan, titignan natin yung limits niya from the left and from the right. Kasi hindi natin malalaman yung sign ni 0 directly from direct substitution sa limits. So, kailangan natin ng limit from the left and limit from the right. So, solving that, so we will get limit of x squared plus x plus 1 over x minus 3 as x approaches 3 from the right. Okay, so dito makikita natin na since 3 plus minus 3, 0 plus, tapos 13. So 13 over 0 plus equals to positive infinity. Since positive over positive. From the left naman, 3 minus, so x squared plus x plus 1 over x minus 3 is equals to 13 over 0 minus. So if gusto nyo i-verify ito, pwede natin gawin yung technique na ginagawa natin kanina. So instead na 3 yung isa-substitute natin dito, 3.1. So 3.1 minus 3, 0.1, which is slightly greater than 0. So 0 plus siya. So dito naman, 2.9 minus 3. So negative 0.1. So slightly less than 0. So 0 minus siya. And positive over negative is negative infinity. And since hindi equal si from the right and from the left, tama pa rin na does not exist lang yung notation natin sa to its limit. Okay? And if we remember its graph, tama naman na if from the right, papunta siya sa positive infinity. And if from the left, papunta siya sa negative infinity. Okay. So some theorems, before we proceed in evaluating infinite limits, for adding and subtracting infinite limit, constant plus positive infinity lang siya. So constant minus infinity, negative infinity. Kapag same sign, so infinity plus infinity or negative infinity minus infinity, ma-retain lang natin yung sign. So, equal lang to sa positive infinity, equal lang to sa negative infinity. Pero if different signs, for example, ay negative infinity plus negative infinity, indeterminate. Indeterminate. Ganun din if negative infinity plus infinity. Ayan. So, ayun, indeterminate uli siya. Ibig sabihin, the limit could either exist or not exist. So, kailangan pa natin ng further steps which we will discuss in a future topic. Okay? For multiplying infinite limits, so ganun lang din. So, constant times infinity, we will retain the sign. So, if negative yung constant na i-multiply mo, so, may iba lang din yung sign. Since negative times positive is negative, negative times negative is positive. Okay. So, for positive infinity, if same signs naman, so correct, positive infinity times positive infinity, the result will be positive infinity. And kapag negative infinity times negative infinity, the result will still be positive infinity. So, same sign conventions lang din na alam natin. So, same signs, multiplying same signs will result to positive infinity, because multiplying different signs will result to negative infinity. Ayan. Okay. So, what if naman 0 times positive or negative infinity? So, the result naman for that is indeterminate. So, again, indeterminate forms the limit could either exist or not exist. So, kailangan pa natin ng future steps which we will discuss in a future topic. So, now that we know infinite limit theorems, we will now try to evaluate infinite limits. First, let us find the limit of this function as x approaches 1 from the left. So, one-sided limit lang tong isosolve natin. Another technique na hindi ko naturo nung previous lesson about one-sided limit, instead na using kunwari 0.9 dito, pwede natin gamitin yung 1 minus na lang to denote na less than 1 siya. So yeah, in this case, direct substitution yung gagawin natin. So, ganito yung gagawin nyo. 1 to the left minus 2. 1 to the left minus 1 minus 2 over 1 to the left squared minus 1 times 4 times 1 to the left over 1 minus 1 to the left. Okay? Solving this, we can get negative 1 over. So, 1 to the left minus 1. So, isipin natin to na as 0.9 minus 1. So, negative 0 siya. So, 0 to the left. Minus 2 over 1 to the left squared. So, 1 to the left pa rin siya. Minus 1, which will equate to, again, 0 to the left. So, 4 times 1 to the left, 4 lang siya. 4 to the left. So, 1 minus 1 to the left, isipin natin, 0.9 to. So, positive 0 siya. Since 1 minus 0.9, 0.1. So, positive pa rin siya. Ayan. So, now, we can solve this. So, since over 0 silang lahat, maging infinity sila, pero yung sign yung titignan natin. So, dito, negative over negative will be positive infinity. Minus, dito, positive over negative, negative infinity. Tapos, positive over negative, positive 4 pa rin to, pero to the left lang. So, positive pa rin siya. So, positive over positive is positive infinity. Ayan. So magiging, so ito, yung theorem natin, negative times positive is negative infinity. And positive infinity minus negative infinity this will be equal to infinity plus infinity is equals to positive infinity. So our final answer here will be positive infinity. Okay? Yan. So, if titignan natin yung graph niya, yun nga, makikita natin na from the left, approaching siya sa positive infinity, and from the right, approaching din siya sa positive infinity. So, ayun, limit niya is positive infinity. Pero from the left lang naman yung sinolve natin. So, tama lang din yung nakuha. Ayan. Now, we will proceed to our next topic about limits at infinity. So, ano ba pinagkaibahan nito sa infinite limits? So, instead of finding limits at a certain point, limits at infinity is a one-sided limit where you find the limit at infinity. So, sa dulong-dulo ng function, mo titignan kung saan nag-a-approach yung value niya. So, ibig sabihin, in this example, so 1 over x minus 1, hanapin natin yung limit niya as x approaches positive infinity. So, ano ba to? So, titignan natin kung habang pataas ng pataas yung value ni x, saan ba napupunta yung value niya. So, makikita natin dito na paliit ng paliit as you increase the value of x, paliit ng paliit yung value ni function na parang nag-a-approach siya into 0. So, we can say that the limit of this function as x approaches positive infinity is 0. Ayan. So, kung titignan din natin yung graph, ito siya. So, as x approaches positive infinity, so ibig sabihin, as approaches positive infinity is, ito yung titignan natin. Kung pataas ng pataas yung x, saan ba papunta yung value? So, makikita natin through this graph na yung value niya ay indeed na nag-a-approach to 0. And in these cases, since we are discussing about vertical and horizontal asymptote, we can see na limits at infinity are used to denote horizontal asymptotes compared sa infinite limits na nagdi-deal with vertical. Ito naman, horizontal asymptotes. Ayan. So, in general, if we encounter a constant over infinity, we can say that the limit is equals to 0. So, yun, nanggaling to dun sa example natin kanina na for 1 over x, yung graph niya ay ganito. If x approaches infinity, f of x approaches 0. So, ganun din sa negative infinity. as x approaches negative infinity, x approaches 0. So, doon to nakuha. So, ganun siya. Ayan. So, additional theorems. So, for limits at infinity, for any x that is raised to n, if n is even, and we are finding its limit as at positive or negative infinity, the result will be positive infinity. So, if n is odd, on the other hand, so kung ano yung sign nung infinity sign, if we are finding the limit as x approaches positive infinity, the result will be positive infinity. So, kung hinanap naman natin ay negative infinity maging sagot. So, ganun lang siya. So, parang kung ida-direct substitution din naman natin siya, kunwari, positive infinity raised to 2, positive infinity. And kapag negative naman, raised to 2, positive infinity. Since kapag even yung exponent, magiging positive siya. And kapag odd naman, kung ano yung sign na pinasok mo sa kanya, ganun yung sign na lalabas. Ayun. So, same pa rin siya nung normal na alam natin. But, in-apply lang natin siya sa infinities. Okay? So, now, we will try to evaluate limits at infinity. So, we will find the limit of this function as x approaches negative infinity. So, kapag polynomial functions, tapos limit at infinity yung hahanapin natin, may additional step tayong kailangan gawin bago tayo mag-direct substitution. Okay, so pwede nating i-express yung function na to by factoring out x squared. So, limit as x approaches negative infinity, let's factor out natin sa x squared. So, maging negative 1 plus 4 over x minus 5 over x squared. So, bakit natin siya pinactor out? Kasi, gusto natin na mapunta sa denominator sila x. Kasi, since we are finding negative limit at infinity, gusto natin na mapunta sa denominator si infinity. Dahil alam natin, kapag nasa denominator si infinity, maging 0 lang siya. Using direct substitution dito, maging negative infinity. Since sa x squared, negative infinity squared, minus 1 plus 0 minus 0. And so, solving this, maging positive infinity times negative 1, magiging negative infinity. So, the limit at x approaches negative infinity is negative infinity. Okay? Ayun. So, tama yung nakuha nating sagot. Ayun. So, in general, if f of x is polynomial, kung mapapansin natin, since yung mga values na nandito ay magiging 0 lang naman, the limit of f of x depends only on the leading term. So, pwede nating i-substitute kagad yung negative infinity sa leading term. So, maging negative infinity squared siya, which will also be equal to negative infinity. Since ito magiging positive infinity times negative 1, negative infinity. Okay? And so, some examples where we can apply this, we will find the limit as x approaches negative infinity of this function. So, pwede lang natin to i-disregard since ang leading term lang natin is negative x cubed. So, ganun lang ang gagawin natin. So, negative infinity cube. So, maging negative infinity is equals to positive infinity. So, ganun lang din dito. Ang leading term natin dito ay x squared. Since ito, nasa denominator to. So, hindi siya yung leading term. Ang leading term natin is x squared pa din. So, isa-substitute lang natin siya sa x squared. So, positive infinity squared is equals to positive infinity. Okay. So, paano naman ganito? Rational number. Ganun lang din. Since polynomial lang din yung denominator. So, kung kunin natin to magiging 1 over positive infinity squared, which will equal to positive infinity. So, 1 over infinity is equal to 0. Since dun sa una nating theorem na tinuro ay constant over infinity is equal to 0. Okay. So, dito, paano naman pag ganito? Kapag ganito, since square root of x squared, ano ba yung leading term dito? Since ito ay 2x, so ang power nito is 1. Tapos ito, square root of x squared, power din nito is 1 kasi square root of squared is 1 lang din. So, pareho silang power of 1. So, since equal sila, pwede natin i-substitute si positive infinity on both functions. So, ganun ang gagawin natin. So, dito, pwede natin i-ignore si minus 4 kasi positive infinity. Pwede natin i-ignore si minus 4 kasi ang leading term dito sa loob ng square root is x squared. So, ayan. Ganun lang ang gagawin natin. Plus 2 times positive infinity. So, square root of infinity squared. So, infinity pa rin siya. And 2 times infinity, infinity pa rin. Tapos infinity plus infinity is equals to infinity, positive infinity. So, yun ang sagot natin. So, that's it for evaluating limits at infinity. And that's it for our lesson about vertical and horizontal asymptotes. So, sana marami kayong natutunan and I hope to see you again on our next lesson. Our next lesson will be about indeterminate form. So, since kanina marami na tayo na-discuss about iba't ibang forms ng indeterminate forms, so, it is time na para i-discuss kung paano i-solve tong indeterminate forms na to. So, I hope to see you on the next lesson. Bye-bye!
Thank you very much for watching this video lecture made by Wisdom Academy PH. If you want to join our mission of providing high-quality educational videos for all Filipinos free of charge, then please consider supporting Wisdom Academy PH by contributing or donating to the following accounts. Kung interesado naman kayo maging parte ng aming organisasyon bilang isang volunteer educator, upang makapagbahagi at makapagturo sa mga taong nangangailangan, then please proceed to this link. If you like this video, then please hit the thumbs up. And if you want more educational videos like this, then please subscribe to Wisdom Academy PH and hit the notification bell for more updates. Watch and learn, God bless, and see you on the next one.